Good evening, everyone. We are from Group of 10. We want to present about COSPITE, combined solar panels and the wind turbine integrated SWRO, and on Warambadi Beach to go to Sumba independent of renewable energy. Next.
I will explain the introduction. With Indonesia being dominated by the sea or waters, Indonesia can take advantage of this resource as capital for the progress of the nation. The sea area itself, which has abundant resource, must be maximized as best as possible to help maximize the utilization of Indonesia's sea area. Many supporting facilities or facilities are needed to facilitate the performance. And therefore, we will utilize the wave energy in the sea to drive turbines which will produce electrical power. This will also support the supply of electricity for local residents and will create an environmentally friendly electricity generator. Next.
Problem. In this research, we can get some formulation of the problem, which is displayed as follows. First, do the eco-friendly renewable energy sources can be applied by using the solar panel system and turbine. Second, do the COSPITE intensify the electrification on the area around Warambadi Beach? And the last, number third, do with this COSPITE of the area around Warambadi Beach can be overcome for drought problem and clean water crisis. The objective, the purpose of this research is mainly to encourage energy generation based on more renewable and environmentally friendly methods, such as utilizing wind and solar energy, especially in areas that lack energy infrastructure, such as Warambadi Beach.
And I will explain about the environmental condition of the COSPITE location. Warambadi Beach is located in on the Pahunga in the eastern part of Sumba. And topographically, Pahunga Lodu mostly covered by land that have inclination of 0 to 8 degrees, with a total land area of 31.09 hectare are 8 to 15 degrees, 8 to 15 degrees of total area of 1,780 hectare are, and with more than 45 degrees with total area of 9 hectare are. And Pahunga Lodu has UV index of 4.5 on average from 7 a.m. to 3 p.m. with an average temperature of 15.4 degrees Celsius. Next. About the solar energy, solar thermal energy is one of the many methods to generate energy. Solar thermal energy uses sunlight to generate electricity using solar photovoltaic or SPV. The system could be classified as low temperature, medium temperature, and high temperature collectors. From these three classes, each of them have differences, and with one of the high temperature classification able to generate this electricity using polar photovoltaic or SPV. Next.
One is wind energy. Wind energy is an alternative energy that has good prospect because it's always available in nature. It's also a clean and renewable energy source. The wind is the air that moves from high pressure to low pressure. The cause of this movement is the heating of the Earth by solar radiation in homogeneous conditions of the planet result in different temperature and air pressure between areas that receive more incredible heat energy and other areas that receive less heat energy, which causes airflow in the regions. Therefore, wind energy can be said to be another form of solar energy. Next.
I will explain about the solar panel. Solar panel are a device that can convert sunlight energy into electrical energy by using semiconducting materials that have two different areas, where one area has an excess of electrons while the other side has a shortage of the electron. The way it works is by utilizing the theory of light as participle. These participles are called photons, which will hit the surface of the solar panel or the surface of the PV, or we call photovoltaic cell, which will push the free electrons in the silicon crystal to move out through the other side of the solar panel. Okay, next. The next one is DS wind turbine. Vertical axis wind turbine with DS type wind turbine is a type of turbine with a rotor that rotates on a vertical axis, which has the main rotor shaft arranged perpendicularly, utilizing the participle or aerodynamic to rotate the turbine combined with the calculation of the gear ratio so that it has the ability to work in areas with minimal wind. The main advantage of the turbine is the arrangement does not have to be directed toward the wind to be effective, so it is suitable for placing in area with varying wind direction. Next.
WRO stand for reverse osmosis seawater. It is a filtration process which can be applied on a large scale to produce freshwater from seawater for industrial process, irrigation, and drinking water. In reverse osmosis, the opposite effect is possible, whereby water will flow from a solution of higher concentration to a solution of lower concentration. The component contained in reverse osmosis are: first, cold water line valve. Valve for connecting to cold water where the water source is in the RO system. Pre-filter, water from the water source line enters the pre-filter first. In a RO system, more than one pre-filter may be used to protect the RO membrane. RO membrane, this membrane is the heart of the RO system. Storage tank, a standard storage tank can hold 2-4 gallons of water. Post filter after the water leaves the RO storage tank. Automatic shut off valve or SOV. To maintain water, the RO system has a valve that shut off automatically. Check valve. This valve is located at the end of RO membrane housing. Current regulator, water flowing into RO membrane is regulated using a current regulator. Drain pipe, this pipe is for removing waste which has impurities and contaminates after being filtered by RO membrane. Next.
Now I'll be explaining the devices and tools of this research. Next. First of all, is the Savonius Darius wind turbine. The Savonius Darius wind turbine is a form of a more compact wind turbine that harnesses the wind, in which it will be transformed into electricity using a turbine generator that is driven by a pair of 2 fins in each wind turbine. This number of fins was chosen because of its high efficiency while still maintaining stability compared to more or less fins of the same size. The size that we choose is a wind turbine 14 meter high with a rotor diameter of 5 meter and a rotor height of 10 meter, with the average Sumban wind moving at 5.8 meter per second, in which a single turbine can theoretically generate 434.16 watt, while having a dimension of just 5 meter times 5 meter times 14 meter. Next. We're also integrating solar panel to the upper half of each 1.2 meter wide fins, with each having a length of 5 meter long. These panels will be placed along the surface of the blade, ensuring at least 50% of the surface is directed at the sun. Each wind turbine will be capable of generating 425 megawatt on the higher end from solar panel alone. Next. SWRO, or seawater reverse osmosis, is one of way to desalinate salt water from the ocean into fresh water that is safe to drink for the people and useful for irrigation and agriculture, and thus have a potential to boost the farming industry in the region. This process of desalination is capable of desalinating 1 cubic meter of water while consuming only 3.9 to 5.6 kilowatt of electricity, in which, of course, the main power source for the WSRO will be provided from the wind turbine system, and thus 100% green energy.
I will explain about the design concept. The first is wind turbine. In the combined solar panel and the wind turbine concept, there are components in the form of solar panel and there is several wind turbine. The combination of solar panel component is located on the blades of the several wind turbine. Next, the water pump. Water pump is an integrated system with the concept of combined solar panel and the wind turbine power plant by utilize the energy generated by the solar panel and the wind turbine generated. Next, then we use the water reverse osmosis as the water treatment system and to clean water.
Okay, and now I will talk about electrical power generated by solar and wind energy. So the first one is, from the calculation we have done before, it is known that one solar panel produces a maximum energy of 450 watts. And for every one wind turbine, it will produce a maximum energy of 434 watts. This means each installation of one COSPITE will produce a maximum of 885 watts of energy. Let's move to the next slide. Okay, according to research by Korean University said that the energy consumption required for the SWRO process is only 2 or 5. And therefore, we use a COSPITE which will have a maximum energy of 7,000 watts, which can meet the energy needs of the SWRO and produce a production that is channeled to the other beach nets. Okay, that's all from our presentation. If you have any question regarding to the focus of our presentation, feel free to contact our team at muutsnry@gmail.com. Thank you. Goodbye.